Hello viewers, in this video we are going to calculate the land surface temperature using Landsat 8 or 9 in ArcGIS. These are the 6 steps. Step 1 is the calculation of top of the atmospheric spectral radiance. Step 2 is the conversion of TOA. And then the third step is calculation of the NDVI, then computation of the proportion of vegetation, then computation of the land surface emissivity, and finally calculate the land surface temperature. So through these 6 steps we are going to perform the LST mapping. So let's start the process. So this is the equation of the step 1, that is calculation of the TOA, and these are the explanation of the symbols. So we at first we need to add the band 10 from Landsat 8 satellite imagery. So at very first we need to download the satellite imagery Landsat 8 or Landsat 9 of which we want to perform the LST. So here we need to add the add band number 10 first. So let's add it, and then go to the spatial analysis tool under the arc toolbox, and under the spatial analysis tool go to the map algebra and then raster calculator, in which we need to perform the equation of the step 1. So let's check the equation. That first one is the M1, and this is the radiance multiband, and we can found it in a metadata. So metadata is provided when we download the satellite imagery from USGS or any other website. So first we need to open that particular folder, and we need to open the metadata, and this is the metadata information, and scroll down, and here we will find the radiance multiband 10, and the value of the radiance multiband 10, and the value is 0.0003342. So let's put it in the map algebra. Plus band 10. So band 10 is the QTL, that is quantized and calibrated standard product pixel values, or simply it indicates the band 10 in Landsat 8. And then AL is the band specific additive rescaling factor, or it is the radiance add band. X is the band number indicating the band number. So open the metadata and scroll down. Here we can find the add band number band 10. So this is the radiance add band 10, and the value is 0.10000. So we need to type this in map algebra or raster calculator. And then y is the correction value for band 10, that is 0.29. And then set the location of the output raster, or and rename it. Suppose we are giving it as radiance. So step 1 is done, and the next step is conversion of the to brightness temperature, and this is the formula, that is BTA or brightness temperature. and these are the indication of the abbreviations. Here K1 and K2 is a constant, and the values we can found the values of the K1 K2 constant in metadata. K2 is the constant, and the value is 1321.0789, and K1 is the also constant, and value is the 774.8853, and we can found it in the metadata. So open the metadata file and scroll down. Here you can see the K1 constant band 10 is the 774 something, and K2 constant we can also found the K2 constant. So just copy it, or we can simply type it in the raster calculator. Here I am copying this and just put it in the raster calculator. So K2 divided by, so we need to divide it using the natural log function, that is ln. So just add the ln function and type the values. Minus 273.15. So just type it and then set the output location again and rename it. Suppose I will give it give the name as this is the BT, it is brightness temperature. So let's name it as BT. Then click on OK. So step 2 is done and BT is derived, and step 3 is the simple, that is calculation of the NDVI. Equation is the NIR minus rate divided by NIR plus rate. In Landsat 8 and 9 we know that the band 5 is the NIR and band 4 is the rate band. So at first we need to add the band 5 and band 4. So this is the band 5 and this is the band 4. Just add it. We can rename it. Suppose we rename it as NIR and band 4 is renamed as rate. Use of the float function can be more effective and corrective, as well as accurate values, accurate output we can derive using the float function. So we put the equation in plot function, under the plot function. And step 3, that is computation of the NDVI, is also done. Then the step 4, we need to perform the step 4. So step 4 is the calculation of the proportion of vegetation, or in short PV. And the formula is the whole square of the NDVI minus NDVI mean and NDVI max minus NDVI mean. So suppose we can remove the radar and air band, as these are not required in the work. This is the NDVI max, that is the maximum value of the NDVI map, and this is the minimum value of the NDVI map. So let's perform the equation in raster calculator, and we need to first use the square function, as there is a whole square of the equation. Then just simply put the equation, or put the values. Here we are using the plus symbol, as there is minus value in the low value, minimum value of the NDVI. So we know the minus multiplied by minus will be the plus. So we are using the plus symbol in first part of the equation, that is NDVI plus NDVI mean. Then set the output location and rename niche. So the step 4 is also done, and step 5 is the calculation of the land surface emissivity, or LST, and this is the equation, that is 0.004 into PV plus 0.986. It is a simple equation, as we have already calculated the PV. We just put the values in the equation box. And the final step is calculation of the land surface temperature, or LST, and this is the equation. LST equals to BT divided by 1 plus bracket, within the bracket, lambda into brightness temperature divided by C2 into natural log of land surface emissivity. And these are the explanation of the abbreviation used in the equation. So let's perform it. So just again open the raster calculator. Then we will take first the BT as per the equation divided by 1 plus lambda, the values of the lambda for Landsat 8 and band 10 on is 10.8. so just simply type the 10.8 in the equation. then into BT or brightness temperature, then into BT divided by C2. Here C2 for the Landsat 8 is the this is the value 14388. So just type the 14388. Then into natural log of land surface emissivity. So take the math function as natural log and put the LSC, computed LSC into it and close the bracket. Then give the or change the file name. So finally derive the land surface temperature map. Just remove the all of the layers. So this is the LST map. Just change the color then as you like. Suppose giving this color lamp and inverting it. So the red color indicates the high temperature and the green color temperature indicates the low temperature. To just checking it, just use the info tool and click on green pixel and the value will be found here. Similarly, if we click on a red color pixel, the values will be found here, and thus the land surface temperature of registered area can be calculated.